Imagine a poison so lethal that just 200 milligrams, less than a pinch, can kill an adult in under 5 minutes. This is cyanide, the CN ion. Invisible, often odorless in its salt forms, and one of the fastest-acting toxins on Earth. Today, we're diving deep into its chemistry, how it tragically hijacks your cells, and the real antidotes used in emergency rooms. This isn't just science, it's vital safety awareness for everyone, from chemists to the general public and those working in high-risk industries like mining. Stay till the end. Understanding this could literally save a life. The cyanide ion, Cn, is a linear anion, a carbon atom triple bonded to a nitrogen atom, carrying a negative charge. Its conjugate acid, HCN, hydrogen cyanide, is a volatile gas often described as having a faint almond scent, though not everyone can detect it genetically. With a molecular weight of 26.02 grams per mole, it's a small but potent molecule. In labs and industrial settings, you'll encounter it as white crystalline salts like NaCN, sodium cyanide, or KCN, potassium cyanide, deceptively harmless-looking substances. This triple bond makes it chemically stable, yet tragically effective when it binds to biological enzymes. Here's the critical process of how cyanide kills. Cyanide rapidly binds to cytochrome C oxidase, the final enzyme in your mitochondrial respiratory chain. This enzyme is essential for cellular respiration, the process that allows your cells to use oxygen to produce energy. By locking the iron in the phase superscript 3 state, cyanide effectively blocks oxygen utilization. Your cells literally suffocate, even though your blood is still carrying plenty of oxygen. This devastating condition is known as histotoxic hypoxia. Absorption is lightning fast, whether through skin, lungs, or stomach. Inhaling HCN gas at just 270 ppm can be fatal in minutes, while ingesting 200 to 300 milligrams of oral KCN is a lethal dose. History is unfortunately full of cyanide's deadly presence, from tragic historical events and wartime suicide pills to modern industrial accidents. For chemists, understanding its reactivity is paramount. For miners, particularly in gold and silver extraction where cyanide is used to leach precious metals from ore, the risks are ever present. Similarly, in electroplating and chemical synthesis, strict safety protocols are non-negotiable. Awareness of its widespread industrial use underscores the importance of robust safety measures and emergency preparedness. Despite its rapid action, there is hope if you act immediately. The time window for intervention is incredibly narrow, often just minutes. Option 1. Hydroxocobalamin. This vitamin B12 precursor is the safest and often preferred antidote. It directly binds to Cn, forming Cyanokobalamin, a stable, non-toxic compound, which is then safely excreted in urine. It's commonly found in fire smoke inhalation kits, as smoke can contain hydrogen cyanide. Option 2. The classic duo. This involves a two-step approach. Sodium nitrite is administered intravenously. It induces methemoglobinemia, creating methemoglobin, hemoglobin with iron in the phase superscript 3 state, in the blood. This methemoglobin then competes with cytochrome C oxidase for cyanide, effectively yanking cyanide off the cellular enzymes. Sodium thiosulfate follows. It acts as a sulfur donor, converting the now-free cyanide into thiocyanate, a much less toxic compound that is then safely eliminated by the kidneys. Remember, after coma sets in, it's often too late. Rapid recognition and administration are crucial. For anyone working with or near cyanide, safety is paramount. Always use appropriate personal protective equipment, PPE, ensure adequate ventilation, and utilize cyanide detectors where applicable. Understand emergency procedures, including the location of antidote kits and how to call for immediate medical help. Knowing the signs of exposure and the rapid response required can be the difference between life and death. While not everyone can smell the characteristic almond scent of HCN due to genetic factors, and victims may exhibit a cherry red skin color due to unused oxygen in the blood, these signs are often too late. Prevention and preparedness are your best defenses. Understanding cyanide's dangers and the science behind its antidotes is not just academic, it's a critical life skill. Whether you're a chemist, a miner, or simply a curious member of the public, this knowledge empowers you to recognize risks and act decisively in an emergency. Hit like if this informative deep dive has enhanced your safety awareness, subscribe for more essential science that impacts your world, and comment below, what other hazardous substances should we demystify next to promote safety and understanding? Your engagement helps us spread vital knowledge.